and welcome. I'm Kyle Simpson, but most of you know me as Getify. I'm Director of Web Futures for my own company, which means I get to spend my time focusing on envisioning the future of the web and then helping empower other people to achieve it. To that end, I've recently partnered with Cadota, who also makes the Tab 9 plugin for your favorite editors. And they have this machine learning model that helps the tool make semantic suggestions to help you as a developer do your jobs better. I'm super excited about this symbiosis between developers and smarter tools, so stay tuned for more in that space. Some of you may know some of the books that I've written, but you may not have heard of this book, the Functional Light JavaScript book. I encourage you to check it out because there's an appendix about today's topic. And yes, I know this word monad is kind of scary, but in these brief few minutes that we have together, I hope that you'll stick with us because I think there's a lot to uncover. Some of you heard this quote before, and you may have wondered, like, where does this come from? Or you may have heard inserted other words besides regular expression into this quote. But I think it's an apt description of kind of the fear that we sometimes have of, are we using the right tools in the right way? Now, it's entirely fair that some of you may feel that this is exactly what I'm about to do with Monads. I understand, I get it. But I hope that you'll keep an open mind because the truth is that regular expressions kind of get a bad rap. I mean, yes, regular expressions can be abused, like, for example, parsing all possible HTML that you ever may run across. That's entirely not the right kind of thing to do with regular expressions. On the other hand, there are tools that can do jobs very effectively. If your job is to do one specific thing, like parse one specific string of HTML, a regular expression can absolutely be that right tool. Speaking of that adage, the right tool for the right job, there's also using the right tool in the right way. If I have a hammer in my hand and the task is to put a nail in the wall and I swing it with my hand, everything works fine. But if I use that same hammer and put it in my mouth and try to swing it, we're not going to get the same good result. So you have to use the right tool for the right job in the right way. And the same is true of regular expressions, and I argue the same is true of monads. We have to select the right tools for these jobs. See, not all tasks are appropriate for all tools. So if we're talking about that generalized task versus a more specialized one, and I think that's what we'll see out of monads in our discussion today. So how are we going to approach this topic of monads? Well, we could start with a very formal statement of the type theory using some type and Haskell-ish syntax. And I don't know about you, but that looks very Greek to me, so it doesn't very much speak to me. So I think we won't go that route. Now, others of you may have taken a different approach and read blog posts where you've heard monads described as burritos or onions or other sorts of silly metaphors. My own favorite personal metaphor is the Rubik's Cube, because the Rubik's Cube basically has these different sides. You don't have to study every single side all at once. You can look at just one side. And that's what we're doing in our brief time together today. We're looking at one specific aspect of monads. But to answer that very prescient question that is in your mind right now, that pressing question of, what is a monad? Well, let me give you an example of an answer to that. Maybe not the only and authoritative answer, but one side of that Rubik's Cube. So we could say that it's a set of rules for how one collection of values and behaviors can interact with another collection of values and or behaviors. So if we squinted at that, we could sort of call that a data structure, even though I know that's going to upset a bunch of people because technically it's supposed to be called an algebraic structure. Ultimately, I find this question of what kind of a distraction because it's focused on the identity from like a type description. It's very academic. And that description doesn't really speak to what we want to be talking about. So I think that there's a better way of looking at this. Instead of the what question, I really want us to look at one specific side of the cube, which is more like the why question. I used some big and confusing words just a moment ago, and I don't know about you, but I didn't even know there was more than one algebra. That's a plural noun. This is like Toto. I've got a feeling we're not in Kansas anymore. But instead of being distracted by that what question of its identity, I think this why question is more useful. So this talk will focus on building an intuition about the why question. What can we do with these things in our code, and why does that even matter? Now, as soon as I dive into a talk on this topic, out of the woodwork, where there'll be waves of the, well, actually kind of description of, oh, I didn't get this exactly right, or I didn't use exactly the precise word. We're deliberately being informal here. We're deliberately trying to be intuitive rather than academic about it. And I understand why the communities, especially functional programming, maybe more so than others, they want to protect the things that are so easy to misunderstand. So I get it, but it sometimes comes across like the functional programming police who are saying, there's only one right way to do this. And I reject that statement. There's not only one right way. We're going to look at just one of the facets, one of the sides of this Rubik's Cube, and we will shun some of that more formal terminology and theory in favor of what can I do with it in code and why would that be useful to me? So boiling this very complex space of category theory and types and all of that down to just two concepts that maybe we can hang on to. We're going to take all of the ideas of interfaces and types and we're just going to put it in this one word type. And then we're going to take all of the ideas about what we do in our programs, the things that we interact with, and we're just going to call those values. And so we'll look at a comparison between explaining a subject as a type or explaining a subject as a value. So give you an example. The number type tells us that there are these things that we can do mathematic operations on, and they tell you specifically what we can predict after we do those mathematic operations. But if I don't have a specific concrete value, I can't actually do math. I need the number 42 so that I can add or subtract from that value. In JavaScript, as in some other languages, quite frankly, these lines are quite blurred. There's not a very strong distinction between types and values in a language like this. There is some, but not nearly as much as in other languages. And so we kind of mix and match these ideas together. And if we were to tease them apart, I would say that types are focusing more on that what question, whereas values, and that's what we want to focus on because they're going to focus more on that why question. So the values are behaviors that we can use, where the types are the behaviors that we can expect. So what does that monad thing mean? Well, I want to frame it this way. I want to talk about the monad versus a monad. The monad being sort of this proper noun thing described by type and category theory, and a monad being this thing that can be in our code. So we have the monad versus a monad. Now, the monad tells us some very important things, some formal things like the three laws, for example, the left identity, the right identity, and the associative law. They tell us things about what we can expect out of any sort of monadic value that we might run across in a program. But it's the data structure itself, it's the value itself in our program that we are going to actually interact with. So where the law might tell us that we can do something like a chain operation, it's the actual value that may have a method called chain or flat map or bind that we can use in our programs. And speaking of these values and their behaviors, we can actually mix and match values and behaviors together. This is one of my favorite things because we get more powerful monads out of doing that. We get things like the maybe, the either, and the IO, and those are monads that we'll see here in just a little bit. So I think we should look at some code to try to make this a little bit more concrete. This is an example using a library that I wrote, which is called Monio, and I'm not trying to sell you on the library, I'm just using it as a concrete way to illustrate in our code. Here with Monio, we have this thing called just. It's just a function. You see on line 1, I call it, and I pass in the value 3. And what I get back is this monad wrapper, this monadic wrapper around the value 3. I can inspect it. I can check to see if something is of that type. Now, as a word of warning, you don't typically see the just as its own standalone monad. It's usually part of this bigger monad that I referred to just a moment ago called the maybe. The maybe is usually a pairing of a just or a nothing. And so you don't see it usually called out, but in the Monio library, I made it its own specific monad. It's kind of serving the purpose of what we call the identity monad, meaning it just holds a value and then lets that value come right back out to be used in other operations. So that's an example of using a monad in code. Now, there's lots more behavior that we want to uncover from that. But if you can get comfortable with this idea that we could take a value like 3 and wrap it in a monadic value, the next most important question you'll wonder is, why would I do that? Why is that important? And that's what we'll spend the rest of this talk focusing on. So to illustrate the monad, but using actual concrete code, here's those 3 laws that I just referred to actually illustrated in code. We see the left identity law, the right identity law, and the associativity law. Now, I want to call out that while we see the actual usage of things like the chain method on line 3, you see that being used, That's just a representation of what the types and the category theory tells us a monadic value needs to be able to do. It doesn't have to be called chain, and indeed you often see it called bind, flat map, other things like that. So this code is not proving all of the monadic theory, all of the laws, but rather for a specific implementation, like the one in my library, and for a specific value, like the value 3, and for a specific set of functional behaviors here, like the f and the g functions, line 11 and 12, it's just saying that for that specific scenario, we can see the laws being played out. We can see that these two sides are equal. And that's what the laws tell us that we should be able to predict. Now, code like this is not good enough if your goal is to be like a mathematician or a theorist, but it's absolutely good enough to start getting our feet wet with actual code. And all we need to take from this is that these things, if we have a lawful implementation of a monad, they're going to give us predictable behaviors. We won't necessarily use these direct behaviors very often, but we'll use lots of other things that build on these behaviors. So speaking of these other sorts of behaviors that we can mix in, I referred to that just a moment ago, I like to call this monads and friends, right? It's like a group of kids that have gathered together in the sandbox to play together. They have lots of different kinds of identities. There's lots of different things. So we can say these other behaviors like semigroup and foldable and applicative, those have these fancy names, and they are very distinct entities within that bigger category theory space. But I really like to just refer to them as friends of monads because in my experience, I often see them illustrated together, implemented together on values, and I think that that makes them all more powerful when they come together. So in my perspective, we'll be illustrating these as all together under this one sandbox that we'll call monads and friends. Now, I wanted to give you a quick example of using a monad, and I'm going to get into more examples in just a moment, but just so that we're not dealing only with this abstract idea of that just. You remember I referred to this maybe monad. Well, here I'm using the maybe monad, and I'm actually invoking another behavior that's been mixed in. This is called the foldable behavior, because the maybe has these two sides. It's either holding on to a value or it's holding on to a nothing. And this foldable says, let's select one of those two based upon what's inside it. Let's select one of those two and call one of these callbacks. So if the nothing is what's inside of it, like a null or an undefined, then we're going to invoke the callback from line 5. But if a value like a string or a cost in this case is there, then we're going to invoke the callback from line 6. That's all that foldable is saying is based on the identity of what's inside of you, call one of these two callbacks and give us the result back. So this is an example of using a maybe monad in code, and we're going to come back to that in just a moment. But I want to motivate the rest of our discussion together by asking this most important question. I've already referred to it a couple of times. Why monads? Well, the answer to that question, as simply as I can state it, is that they're a tool just like anything else, like regular expressions or any other thing we use in code. You find a problem, you find the right tool, you use the tool in the right prescribed way, and you solve the problem. Now, monads just happen to model and solve problems differently than you're used to. But that actually opens up a whole world of other additional possibilities, and that's what gets me so excited. Now, by the way, when I show you these sorts of examples, I want you to be careful about jumping to the conclusion, oh, that's not more readable, that's more confusing. Of course that's going to be true, because anything that is less familiar to us is automatically going to be less readable to us. So the first time that you see these sorts of examples, they're less familiar and therefore less readable. But if you push your boundaries a little bit, if you practice with them and you try them, then the unfamiliar becomes familiar, the unreadable and ununderstandable becomes readable and understandable. So this will be a journey. This is not an, aha, I get it all of a sudden in just 20 minutes together in a talk. But I hope that it whets your appetite, that you want to dig in more and practice with these things. So what are some things that we struggle with in our programs? What are some questions that we might ask of our programs? What problems might we face? And I'll say that these are all problems that all of us have faced in all our programs, and we've also already got lots of familiar solutions to these problems. We're just looking at another way of solving them that opens up the door to potentially better usages of these patterns in our code. So we may choose a value or a fallback value. That's a very common task. How do I do that? We may want to gracefully handle an exception, maybe one that was unexpected or one that was expected. And we also might want to wrangle all of the crazy, maybe asynchronous I/O side effects that are happening in our programs. These are all very common tasks, but there's an infinite list of other ones. These are only a few that I chose to call out in this talk. So let's start with that first one. How does the maybe allow us to choose a value or a fallback? This is just one way of using our maybe monad. So to describe it, as I said a little bit ago, we have this thing called a maybe, which is really just under the covers holding something that is either an affirmative value, like the number 42, the number 3, a string, or it's basically representing a nothing, meaning like a null or an undefined in a language like JavaScript. So we use this tool, this helper that comes along with the maybe function, and it's called from. And under the covers, the from is essentially doing an if statement. It's saying, if this thing is null or undefined, then we're going to represent it as this maybe nothing. And if it's a value, anything else, like the number 42, we'll represent it as a just. You remember I said that we don't typically see the just or the nothing standalone. They're usually part of this parent monad called maybe. It's just that in Monio's case, it was also convenient to have them be able to be used separately if you wanted to. But we're using maybe here, and we're saying maybe.from, and that gives us a maybe just. You can see that that's how it's inspected there on lines 2 and lines 3. We can inspect it and see that it's holding a maybe just wrapped around that value 42. The same thing when I pass in a .from null, like on line 6, we're getting a maybe nothing out of that. Now, I want to call out that on line 8, I'm not using the maybe from. That's the maybe unit constructor. And here there is no selection logic. It's not saying null or not null or anything like that. It's just simply taking whatever you pass and wrapping it in another monad. So in this case, we would take the empty, the maybe nothing, and wrap it in a maybe just. And that's what you see illustrated on line 8. Maybe is kind of this, it's referred to as like a sum type because it can either be a just or a nothing, depending on the conditions of how it was constructed. And that's what the from helper is letting us do. So let's take a more real-worldish kind of example. This is from some actual code that I've been working on. It's like a media app. It doesn't really matter what it does. But here you can see that I'm wanting to select out a value and do some matching. And aha, I'm using a regular expression, see? Because I have this string. It's coming from a drop-down of various MIME types. And I want to match like video, audio, or image from those MIME types. And if that's there, I want to match that out. And if not, I want to fall back, like I'm doing on line 3, I want to fall back to just this quote web value. So I'm selecting out a value from a regular expression, and if there's a failed match there, just select the default value. Now you probably recognize code like this. You may have done it with the ternaries, you may have done it with if statements, but it's a very common thing to try an operation and substitute a default value if we don't succeed. So that's exactly what's happening here. And this solution, quite frankly, is familiar to all of us and works, but we would classify this solution as a bit more imperative. And what we're looking for in functional programming is to look for ways to solve those problems in ways that compose better with other solutions. This is kind of like a meta level here because it's not just about this problem, but about other problems I'll solve alongside this in the code. And if I do the solutions in the right way, they will pair together much more effectively than imperative code typically does. So that not equals null check there, we can actually model using the maybe.from. You see that there on line 3. I'm using this maybe.from to model that selection logic of, did I get a value out that was an actual match from the regular expression, or was it null? And I drop that into this thing called a maybe. And then again here, using the foldable nature, I select out either a function that will return me back my default value, or this identity function, which the identity function just returns whatever's in it, whatever's passed to it. So we just either select out a default value or select out the value that we've now selected. So we're allowing the maybe monad to do that selection logic through the from utility for us and to hold on to that nature of, is it a just value or is it a nothing? In isolation, that doesn't look particularly exciting. Maybe a slightly more complex example might help to motivate it a little bit more. Here I'm doing some nested ternary logic, which could be exactly like some if statements that you've written. I'm just saving space on the slides. But I'm not only doing that not equals null check like on line 2, but I'm also doing an operation on a value if we found a value. Here I'm shortening a string. I'm putting a ... ellipsis on the end of a string if it's too long. So it's kind of an operation where I'm mapping it to some other value if I need to. Just conditionally, of course, but mapping it if I need to. So we could do this very imperatively the way that we're doing. We can either select the value or a default, and if we select the value, then we can also apply some additional logic. But this is where we get to start bringing in more of these functional behaviors, more of these monadics and friends behaviors. So here what we're going to do is, again, use the maybe. We do the maybe from there that you see on line 2. And what we're going to do is call the dot map on the result of that. And the dot map call, by the way, is another nature that we get kind of directly from the core of monads, because that comes to us from the functor nature of monads. They allow us to map over things. And if that sounds a little bit scary, you've actually probably seen this a lot when you've dealt with arrays in your programs and you've done a dot map on an array call, and it executes a function against all the values in that array and gives you a new array back. That is exactly the same concept here. There's only one value to be mapped over, but what we're saying is, if I have a maybe just, I want to invoke this map method to do something on top of it, and that's the selection logic to decide if I need to truncate the string with an ellipsis or not. Now, the cool part about this map call that's happening on line 3 is that if under the covers that maybe.from had produced a nothing value, then the map call that comes right after it is just a do nothing. It doesn't do anything when there's a maybe nothing involved. It's only invoked to do something useful if there's a maybe just. So we would skip over line 3 in the null case, in the nothing case, and then just go directly to line 6. And again, you see the foldable nature there. That's how we select out either our fallback value or the value that has now been terminated with the ... ellipsis on the end of it. So here's another example using the maybe in a slightly different way. This is selecting properties, and this is maybe one of the more common examples that you see with maybe. It's selecting properties on a nested object reference, like we have entry.media.source.url. And if at any point in that chain a property is missing, if we're just using the dot operator, then it might fail, which is why recently some of you know about the optional chaining operator, that question mark dot that you see there on line 9. This optional chaining operator just sort of short circuits out and doesn't do anything else if it runs across a missing property. So a lot of people are really excited about this feature. I think it's a great feature to be added to the language. But I wanted to show you how we can do this same kind of thing, this optional chaining thing, using something like maybe. This is a very common illustration of that use case. Same object here. We have the entry, the media, the source, and the URL. But you'll notice that I'm dropping it into maybe from, and I'm using this, this chain method. Again, because maybe is a monad, we're going to be able to chain from one monad to another monad instance. And that prop function, if you'll notice there, it's giving us back another maybe every time. So at each step, we're checking to see if the thing that we pulled out was null or undefined, if it was empty in some way. And if so, we switch to a maybe nothing, which effectively short circuits the rest of those .chain calls. You probably recognize something like that short circuiting from promises, for example. If you have a bunch of .thens on it and you get an exception or a rejection in a promise, it just skips over all of those and then goes to the end wherever your catch handler is. It's the same kind of thing here. So this safe property access just kind of short circuits out to a maybe nothing if any one of those property accesses fails. That's why on lines 10 through 15 it succeeds, but on lines 17 through 21 we've exited out early, if you will, and all the rest of the chain calls are effectively ignored. So yet another example of being able to put this selection logic into the representation of our value using a utility like maybe from. It puts that selection logic in so that we're sure that this value is going to behave in a very predictable way. Now I want to call out this undefined versus this maybe nothing, the line 13 versus line 22 here, because what I'm going to say is that even though these are both empty values in a generic sense, actually these are not the same, because a maybe nothing is far more powerful than just an undefined value. A maybe nothing, even though it doesn't seem like it's doing much, it's a monadic value and it gives us lots of predictability in terms of how it will interact in the rest of our program, where the undefined you have to special case with if statements all the time. And so that's why, one of those reasons why moving towards this monadic representation can open up the possibility for us to do more things and do things better in our programs. So the second question that we wanted to jump to is, how do I gracefully handle exceptions? Again, exceptions that either I know are going to happen or exceptions that were unexpected, but I still want to gracefully handle them. We're going to use what's called the either monad for that. And by the way, the either monad is very similar to the maybe monad. They're both these sort of sum types. And in the examples I'm giving here, you could sort of interchange them. You could have used the either for what I just described maybe doing, and you could technically do what we're doing here with a maybe. But it's a little bit more convenient this way, I think. So that's how I chose to illustrate it. The either is a pairing, a monad, that it will select either an either right or an either left. Now, an either left is usually reserved to represent like the exception or the error message, whereas the either right is designed to represent like an affirmative value that still has operations and behavior that we want to do. So we could wrap up the result of any operation in an either left or an either right, and then because that is monadic, then get exactly the same kind of benefits we just illustrated with the maybe, that it will have a predictable behavior, it'll have short circuiting, all of those sorts of things. So you notice here I can construct either.left on line 1, either.right on line 5. And by the way, the either and the maybe, since in this implementation, they're both implementing the foldable interface, that so-called semi-group here. Because of that, we can actually take a maybe that's a foldable and consume it into an either using this from foldable interface. So you would typically do an exception handling using try-catch. It's the most common way that people do this in their code. Now the try-catch, there's nothing wrong with it, but it does get very hairy to compose lots of nested try-catches as you go throughout all of your programs, and you have lots of layers deep of the call stack and things. So what we would like to do is actually have a slightly better way of wrangling these exceptions, and that's what we're going to illustrate with the either. Now I'm going to use this helper that I'm going to define called safe here. And you'll notice that basically what safe does is it tries to call a function, and if that succeeds, it puts the result in an either right. And if it fails, it puts that result into an either left. So it's very similar to the maybe from. It's just doing that selection logic for us. Which kind of either do I need? And if we use that safe as a wrapper around, for example, the JSON parse, line 8, we can call parse JSON. We can parse some JSON, and if that fails in any way, we know we're going to get back out an either left, which is going to short circuit. So the next dot chain call, it'll just be skipped, line 9. But if it succeeds, if we're able to successfully parse the JSON, then we'll get back out an either right, and then the chain call there on line 9 will invoke the next step in this process, which in this case is our safe wrapper around the save to DB function. So we would only call that save to DB if the parsing of the JSON worked, otherwise we would skip over it. And again, you see the foldable here is kind of a convenient way of illustrating how at the end of all these monadic operations, how do I reduce that to something that I can actually look at, like alert an error message or grab that value and put it in the DOM or something like that. So fold is just one of the various convenient ways that we can, at the end, kind of get that value out. We select either the either left case that calls our error function with our alert error, or the either right would have invoked, in this case, the identity function. So how are we going to manage side effects? That's our last question that we want to ask, and this is the most complex of all of them. I'm using what's called the IO monad here. Now the IO monad is a special kind of monad that wraps up not just number values like the number 42, but actually functions that can produce values like the number 42. So line 1, you see an IO wrapping around, in this case, an arrow function that returns the number 42. It can wrap around any pure function, so it doesn't have to be ones that return constant values like you see here. But what's special about it is that it turns those functions into what we call lazy, meaning that we can compose all of these functions together. For example, we see a hello function, a hello IO monad wrapped around a console log statement for hello. We see this IO wrapping around the console log of world to make that world IO. And then we compose those two on lines 9 and 10. But you'll notice that in all of these cases, like lines 2, 3, and 10, none of that is getting invoked until we call .run. So we can compose these things, we can compose all of these complex side effects in our application, but none of them actually are affected, none of them actually are executed to change the state of our app until we call the .run. That makes it a lot easier to pull these things from all different places and then have a nice predictable ordering. So the IO monad, the more complex our apps get, the more it starts to shine in terms of helping us wrangle all of these side effects. By the way, lots of side effects that we could consider, things like console log are very simple, but like saving to the database, writing to the DOM, even asynchrony, all of these are things that are side effects that something like the IO monad can help tame. So let's take a look at an example, again, from that code base that I was talking about. Here I've got an array called entries, lines 1 through 4. I've got an array called entries, and I have these side effecting functions, lines 6 and 10. The first and the second functions are pulling values out one at a time, and that's changing the state of that array. So these are side effects, if you will. They're changing the state of this global variable. And then I'm doing a console log statement on line 17, again, another side effect. Now, all of that side effecting is composed in this one function playlist, but it's done. We did so very manually and imperatively. And then we invoke the playlist function on line 20. So that works, but the more complex our apps get, being able to pull these things together into bigger and bigger functions and make sure that things happen in the right order, especially when asynchrony comes into play, that gets really difficult. So here's where the IO monad could solve this in a different way. We're going to have that same global array, but we're going to wrap every function that's doing these side effects in an IO monad. So we have this IO that's called first, that's wrapped around the modification to pull off the first element from the list, and then we have another one called second to pull off another element from the list. And then you'll notice lines 11 through 14 that we're basically doing the composition of all of those IOs together, and we're calling this special function called concat. Now, that's delegating to this other thing, this concatable behavior. I think I said a moment ago that fold was the semigroup. It's actually concat that's the semigroup, so sorry for that. Concat here is the semigroup. And that is what defers or delegates down to the underlying values if there's some concatenation to occur. So concatenation might be something like two strings being concatenated together, or it might be two numbers being added together, any sort of intuitive lower level value being concatenated together. In this case, since our IOs are producing strings, we're able to concatenate those things together, just like we were doing before. And then the final line 14, that chain, takes the result of those concatenated, the IO that's holding those concatenated values, and actually logs out that value. So again, what we're doing is able to move from a more imperative, spaghetti-ish kind of mixture of all this code into one nice, clean listing, very straightforward listing of what each of the operations are that we want to perform. Now, I want to talk about some specific things with Manio's IO as I begin to wrap up this talk. We have what's called this do syntax that comes to us from Haskell, and you'll notice that it's represented here in JavaScript. We appropriate that idea. We do something here in JavaScript called this generator with the yield keyword. So what we're doing is basically getting a kind of compromise between the very monadic, chainable style that's traditional in functional programming and something that looks a little more familiar to you. This kind of looks a little bit like async await style programming. Under the covers, the yield keyword is calling our chain method and chaining our IOs together. So it still performs monadically and gives us all the guarantees and expected behaviors that we want. But it nods to a slightly more familiar and easy to accept coding style. And so that's one of the advantages of this do syntax. And that is something that the implementation in Manio of the IO monad supports. And this is a more complex example. I don't want you to get too wrapped up in the usage of these maybes and eithers and things, but I want you to focus specifically on line 63, because here I'm doing something, again, that looks very much like an async await style. This wait function is actually creating a monad wrapped around an asynchronous timer. It's kind of faking that there's a delay of a lookup in the database. And so there's an asynchronous timer that's going off, and that resolves that monad and then moves along. And the reason I wanted to illustrate this is because Manio's IO is actually a transparent transformer over promises, which kind of makes it like the task monad. So it lets us do this async await style, either in the do syntax like we see here, or in the chaining syntax that we saw earlier. And that's what I'm kind of excited about with this IO monad, this concept, because you can mix so many other things into it, like the task behaviors and reader and all these other monad behaviors into it. So along with all of the friends in the Manio library, it becomes kind of this one size fits all, or the one ring to rule them all kind of monad. And I've started to use this in a lot of more places in my program. And that's what's got me excited and wanted to to give you this talk today. So as we wrap up, let me just give you a quick summary. We talked about this monad type and interface idea, and that tells us that we can make these values that have these sort of abstract guarantees about what their behavior should be. But the real focus that we've spent in this talk is on what can I do in my programs? Like, what problems do I face and how can I solve those problems? So I hope that you have gotten that this is not an all or nothing thing. You don't have to be all functional, you can sprinkle in little bits of functional, like pure functions, and use a maybe monad, and then maybe use an either monad at a later time. You can progressively move through that. And that's kind of the takeaway from my Functional Light JavaScript book and the associated course from Frontend Masters, is to just go through this little by little instead of feeling like you have to rewrite the entire program. Again, you want to develop some intuition and familiarity with these things so that they become more readable. And my caution to you is, don't be so scared about the confusion of it that you run away, because then you'll never get to that point where it feels more understandable. So I hope that maybe I've convinced you to try out Monads and try to explore them a little bit more. There's lots of great resources on that topic. Oh, and by the way, you should probably also use regular expressions. Thanks very much for coming to my talk, Mo Problems Monads. I'm Kyle Simpson, Getify.
Kyle has arrived, the man, the myth, the legend that is Getify.
Hello, hello, hello.
That was a brilliant talk. Thank you very much for giving it.
Thank you.
To everybody watching along, please do pop your questions into the Q&A section. Can't see any in there at the moment. So I'm going to ask you, Kyle, if you could tell us a little bit more about your amazing book that everybody is in with a chance of winning today.
Yes, we gave away or are giving away the Get Started book. So many people probably know about the first edition of the You Don't Know JS books. Those were written starting back in the end of 2014 and into 2015. And there was always a plan to come back and update those books. Unfortunately, it took a lot longer than I expected. So the beginning of this year, I finally picked up that work and started putting out the next edition of those books, because it turns out a lot has changed about JavaScript, but also a lot has changed in terms of what I know about the language. I know more of it than I did before, and so I wanted to update that. So as things currently stand, 2 of the 6 books have been rewritten for the second edition. It turned out they were a complete rewrite from scratch. I totally started over with empty files. And those 2 are out. The first one is called Get Started, and the second one is the familiar Scope and Closures book. So all the attendees, we've got the Get Started book, the first in the second edition books, the rewrite.
Wow, you all have been very busy. That's a lot of writing.
It is a lot of writing, for sure.
So I can't see any questions have come in just yet. I'm sure people are furiously typing as we speak. But
or I put everybody to sleep. One of the two. I'm not sure which one it is.
One or two. I'm sure it was the former. So I'm from Cornwall, and your workshop that you did down here many, many years ago now is almost famous locally.
Really?
Yeah, we keep on getting. So I used to work for the organisation that brought you down. We keep on getting asked for you to come back. So do you fancy a trip to Cornwall for holiday?
I would love to come to Cornwall. It was such a beautiful area. I've been to London like a million times, right? I've been to England. I actually in college studied at Oxford for a summer, so I was in that area for a while. But I had never actually seen like the really pretty parts of the UK, of England before. And that's where I got to see. We came out to Cornwall, and then after that we went up kind of a little bit further up the coast and stayed at this like hotel that overlooked the ocean, and it's just a beautiful part of the world, of the country. So yeah, anytime we get a chance to make something like that happen again, I one of the cool parts of my at least former life, where I was traveling all the time. I don't travel much now, but when I was traveling all the time, is getting to see these beautiful areas, and Cornwall is definitely high up on my list. It was beautiful.
Awesome. Well, I'll pass it on to the team.
Please do.
Pleased to see. So when we look at your talk, is it safe to say that you do functional programming more than object-oriented programming, or is it very much a mix for yourself?
I would say it's definitely a mix. I don't do a lot of what I would call object-oriented programming, because typically when you hear that term, you think classes. And I'm actually not a big fan of writing class-oriented code. So I wouldn't do a lot of what we would traditionally call, say, from the Java or the C++ tradition of what we would call object-oriented.
But I do work a lot with objects, which in sort of a more broad sense is object-oriented. It's just without classes. So I use a lot of very basic architecture, the module pattern and objects as namespaces. And I even use what I call object delegation, which is leveraging the prototype chain in JavaScript and things of that nature. So sort of generally speaking, I do object-oriented. The functional aspects of my program are a relatively recent addition to my programming toolbox. And by recent, I would say over the last 3 to 4 years, I've started to try to understand this space. And that's one thing I'd like to emphasize for anybody that's listening in, is that this was not an overnight thing. It's not like I read some book or I watched a conference talk or read a blog and then all of a sudden the light bulb went off. It's been a long adjustment process. And even to this day, I've been actually writing an app where you saw in the talk some code snippets from a real app that I've been writing for myself. And I start out writing code imperatively because that's still my comfort zone. It's still what I've done for 20 plus years. And so I start out writing it that way. And what I have been able to accomplish over the last several years is be able to look at a piece of code and then sort of Neo in the Matrix style, be able to see beyond that to the pattern behind what I'm doing. And that's when what can emerge is the alternate option, doing something with functional. What I know about functional programming is that it offers many more guarantees. It offers better testability, more readability, even though people listening maybe think, oh, that looked much less readable. Once you actually get used to that style of code, those things actually jump out more quickly at you than you typically would with imperative code. You don't have to do as much mental execution. So all of these are things that I know to expect from functional programming. It's still difficult for me, frankly, to author a program from scratch using those techniques, but I've gotten better at the case of writing something, and then as I'm getting along and understanding a little bit of what I'm doing, kind of micro refactoring to use these principles little bit at a time. So I would say that I'm in the most truest sense of the word a multi-paradigm programmer, which means for any given line or any given set of lines of code, I'm going to use whatever pattern is most comfortable, whatever pattern makes most sense, and ultimately, whatever pattern will communicate best the ideas that I want to get across. What's happening for me over the last several years is that that's starting to be more functional in nature, but it isn't even yet the thing where that's automatic. It's still a thing that I have to work towards.
Okay, so the questions have started rolling in now,
okay.
So we can move on to them. So we've got one here saying, many of the patterns you showed look familiar. Is there a benefit to being more conscious of when I'm using a monad-like pattern?
Yes, I think that's actually, this is a great question to start off our Q&A with. That's really the core essence of this talk, is for you to begin to realize that all of programming is recognizing a problem and then trying to substitute in a known solution or work out a solution to that known problem. All programmers, regardless of what paradigm you use, follow that practice. They look at something they want to do, they try to do it, they run against, it's not doing what I want, that's the problem, and then they solve that problem using what they have already seen before or what they can Google or Stack Overflow. They use those solutions to solve the problem. That's the general pattern that all software development follows. And so all I'm suggesting here is that there's this set of tools that solve problems in a different way than what we're used to. And I include myself in that because I didn't start programming in the functional tradition. But they're all problems that we all face. And I only called out 3. There's literally an infinite list of problems that we face. Functional programming offers what I think is some really compelling alternative ways of modeling the solution. And one of the biggest reasons why we want to do that is, as I said, it can produce more readable code. It will produce more testable and more verifiable code. Like, for example, you could literally get to the point where you could know for sure, because it's based on math. Even if you don't know the math, it's based on math. And you could know for sure that a piece of code will have a certain outcome, even if you haven't run the test suite. And I just imagine to myself, what if I could have that level of confidence in my code that before I even run the test, I know exactly what it's going to do. I know what's going to succeed, what's going to fail. That's the offered principle here. But I think even more than all of those benefits is that the functional way of thinking about our programs to create these tiny pieces that compose more cleanly together, what that offers is that once you have gotten familiar with those different pieces, those are Lego pieces that fit together much more cleanly than any imperative code we've ever written. So I don't know about people listening, but I've always felt like, man, I'm having to fight against my program. The more imperative and the more if statements and the more try catches I have to wrap around things, it gets harder and harder to wrangle through the code. If you're doing functional programming the right way, and I admit that it takes a while to get there, but if you're doing it the right way, the further you get into a program, the easier things get, because things start to fit together the way Lego pieces are designed to do so. So it's really training ourselves to move from that more comfortable but harder to maintain style of code to a less comfortable initially, but much more easy to maintain and verify style of code down the road. That's what I hope that you get from this talk. That's what you want to look for, those problems, and then say, I remember that there's a tool that looks like that. Just like if you were building a home and you're like, I need to put a nail in the wall, I remember that the right tool for that is the hammer. That's what we want to get from this.
You say that, I nailed in a hammer with a drill today.
Oh, you know,
and hammered in a nail with a drill.
You know, sometimes you gotta use whatever tool you have available to you, but ideally we want to use the hammer.
Yeah, definitely. That does lead us nicely on to another question we've had come in. When would you choose functional programming over any other paradigm, e.g. RxJS versus Monads?
So it's not an either or, it's not mutually exclusive. RxJS is actually, in a lot of ways, very compatible with functional programming. As a matter of fact, in the Functional Light book I talked about in my talk, which you can get out on my GitHub the same way you can get the other books. In that book, I have a whole chapter talking about applying functional principles over time. And the way we do that is basically through observables, which is what Rx is. So Rx is actually very compatible with the way of thinking about functional. I don't use observables an awful lot myself personally, but that doesn't mean that it's an either or, that you have to pick one or the other. The thing to recognize is that when you want to use functional programming is when it is ever the case that you have a piece of code that you want to be isolated from any other piece of code. In other words, if you're on line 5,000 of your program and it is an impure function call and it references who knows what else from other parts of the program, to know what line 5,000 is doing requires you to mentally execute lines 1 through lines 4,999 to compute the state of the program in your head so that you can understand and predict the outcome of line 5,000. And I don't know about you, but I'm not particularly good at executing JavaScript in my head. That's what the computer's good at. So functional programming offers the promise of, what if line 5,000 could be computed completely in isolation of anything else? Would that make you a more effective programmer? So I hope I don't sound too glib when I say there's almost no code that can't benefit from that. Some pieces of code benefit better from low-level simple things like simply making it a pure function call. Some bits of code will benefit from using something a bit more exotic and involved like a monad, and some will benefit from patterns that, quite frankly, I don't even understand yet. There's a whole road that I'm still headed down trying to learn. But I don't think there's any code where you could say, oh, you definitely shouldn't do that functionally. Even side effects, which seem the antithesis of functional programming, can be wrangled better if you use the IO monad. So if you'd asked me this question, say 2 years ago, I probably would have answered it by saying, well, you know, anytime I'm going to do side effects like managing the DOM, for example, I'm probably not going to worry too much about functional. And now when you ask me that question, I'm going to say, if I need to do side effects, I now understand that there's a tool that's actually well designed for that problem. And that tool is the IO monad. So it is always the case that you will be able to learn a pattern. You may not recognize them always off the bat, but you will be able to learn a pattern. If you apply yourself to try this, you'll be able to learn a pattern that should be able to address basically anything that you run across. I don't think there's very many tasks that you would ever do in programming where somebody would say, definitely not, never do functional. There is often the case the opposite, where there's a very dogmatic, like it has to be all functional or none. And I don't like that dogmatic perspective either. You can have one line of code that benefits from functional programming and another line of code that you don't have the right tool for, or it's not appropriate for. And that's okay, because I ultimately want you to have the pragmatic, balanced approach to your code that lets you communicate better and lets you ship code. I don't want you to be stuck in the mud, if you will, like, oh, I can't do it perfectly. So, don't let perfect be the enemy of good. Pragmatically decide on every line of code, is there something that I know, is there a tool that I know that could make this line of code communicate my ideas better, be more verifiable, be more testable, be more independent? And if so, use the tool. And if not, don't use the tool.
Yeah, and I think breaking down your code into line by line like that and looking at it is a very good exercise, particularly for people who are maybe around the junior level or even below, and get input on it as well.
Yeah, absolutely. We need to be able to look at our programs and ask questions of our programs instead of just like, oh, it works and I don't know why and I'm not curious. We should ask questions of our program. Hey, why does that do what it's doing? And how do I make it do that even better?
Okay, so we're running out of time. So if I could keep you short on this one,
okay,
and then hopefully we'll have a little bit longer one afterwards.
Okay.
Will native JS support monads and other structures one day, do you think?
I think it's very unlikely that native JavaScript ever grows more than the syntactic capabilities that it already has. So we have functions, we have closure, and if you adhere to the principles that functional programming requires, you can do everything that you want to do in functional programming. That's a somewhat controversial claim, because a lot of people would say, no, JavaScript is a terrible language to do that in. I happen to think that JavaScript, native core JavaScript, is actually one of the best languages to express functional principles in large part, because JavaScript is not constrained by the same complexities of type-based languages. So I actually think, rather than being a weakness, that's a strength of JavaScript in this space. That is a controversial statement, but it's my position on it. So I do think that native JavaScript already supports the things that we want. And then we simply bring in libraries that, just like we're bringing in an RX to do an observable, we can bring in a monad library. I think it's unlikely that they will ship these, because there will always be so many different opinions on what it should be called. Should it be chain? Should it be flat map? Should it be bind? We'll never be able to agree on the actual names of these things. So the concept can exist with what we already have, the primitives in the language. The concept can be layered on with userland code.
Awesome. And this is the final one, and it will have to be very short. And it might be one that you refuse to answer and get people to follow up on Twitter.
Okay.
So somebody here said, firstly, thanks for the clear explanation of monads. They followed along on Twitter for a little bit, and they've asked if all of the community pushback on terminology is discouraging a deeper dive into this.
It is absolutely a discouraging kind of thing that I have faced for a lot of my career. I wanted to learn functional programming 20 years ago when I first heard about it. And I spent many, many years, more than a decade, discouraged by, oh, well, you don't know the words and you don't know all the notation and all of that, so you can't really learn. What I'm hoping that I'm doing is helping to lay some breadcrumbs that help people come along on this discussion. And one of the things that we have to accept is that there will be people that are challenged by that. There are people that are used to being the gatekeepers of that sacred knowledge, and I'm trying to open this up to a broader audience and conversation. So I think there is a way, but it is not a smooth road. It can be a very bumpy road.
And on that bombshell, we're going to have to leave it there. Kyle, thank you very much for the talk and for the amazing Q&A. They were brilliant answers to the questions. I'll be in touch about coming to Cornwall, and anybody else who wants to join us.
Awesome.
I'm joking. No, it was really, really good. Thank you very much. To everybody else, the next talk is just about to start, and we will see you here in about 20 minutes for the next Q&A. So, Kyle,
thanks a lot.
Thank you.
Appreciate it. Bye-bye.